Calculus.
Yes.
Okay? This might not be the last time I give you notes because you could have me in calculus next year.
I thought you were saying like tomorrow.
No. In pre-calculus, during the school year 2018 to 2019, this is your last set.
Holy crap, guys.
No, we won't ever see you again. I'm just kidding.
You'll see. Okay. All right. Before I teach you about the cross product, I want to remind you how we take a 3x3 determinant. Okay, so we need to flash back to first semester.
A, B, C.
Okay, so you remember those bars for a matrix? Typically, matrix bars look like this, right? But when we cut that piece off, we are talking about a determinant. Okay, so I'm going to just randomly make up a a 3x3 determinant. Okay, Monique says our first job is to copy paste the first two columns, and then I hear. Okay, what do we do as we cross? So we have 1 plus 4 plus 0. We add those together and then subtract the sum of our up diagonals.
Yep.
Yep.
Yes, we actually got that pretty good. Crushed it.
I'm actually very impressed.
Terrific job.
Okay, with our collective,
Recollection.
yes. Now, if you were not one of the ones throwing out like, hey, this is how we do it, it's fine. You're going to get enough practice today to where it's going to come back to you just fine. But when you have a 3x3 determinant, you're going to copy paste those first two columns. We add the products of our down diagonals and subtract the sum of our up products. Okay? We'll go through the motions plenty of times. What the heck does that have anything to do with vectors?
It's a determinant.
We have something called the cross product. Okay? And
Is this one?
just hold on. So yesterday we talked about the dot product. Today we're going to talk about the cross product. There are actually two different ways to multiply vectors. Now, when we use the dot product, what kind of answer do we get? We get a scalar, okay? Well, once we get into 3 dimensions, we can take the cross product of two vectors, which means when we multiply vectors, we will now get a vector for our product. Okay? So, this is what's happening. If I have vector u, u1, u2, u3, and vector v, v1, v2, v3, then the u cross v, so the cross product of u and v, is the 3x3 determinant of ijk, u, v. But I'm not just kidding because that's really how it goes. Okay. I, J, K will be that first row. And so every time you do a diagonal, it's going to have an I or a J or a K in it. Because our answer needs to have I, J, and K because it's going to be a vector. Okay? We will talk about the relationship, but U cross V is not the same as V cross U. It does matter where you put the vectors. Whichever one comes first goes in the second row. Whichever one comes third goes in, whichever one comes second goes in the third row. Okay? But when we do an example, we will talk about the relationship as to how U cross V and V cross U are different. Okay? But our cross product is a way for us to multiply two vectors, and our answer is a vector. The dot product, we multiplied two vectors, and our answer was a scalar. Okay? And notice how we're using the two different types of notation for multiplication. The dot yesterday and the crisscross today. Okay? So, I would like you to go ahead and write down these two vectors. Just write them down. Okay, so the first thing we're going to find is U cross V. The first thing we're going to find is U cross V. So, in order to calculate our cross product, our first row is IJK. Then, since U comes first, we'll put in the coefficients. 6, 2, 1. Okay, we're going to put in the components. And then our last row will be the components of V. 1, 3, 1. Okay, so now we go through the motions like we did in chapter 8. We're going to copy paste column 1 and column 2. Okay, so let's first start with our down diagonals. I times 2 times 1 is 2I plus j times 1 times 1 plus k times 6 times 3. Then we will subtract our up diagonals. So 1 times 2 times k plus 3 times 1 times I, bless you, plus 1 times 6 times j. So we have our down diagonals, our sum is in parentheses, minus the quantity of the sum of our up diagonals. So now we have 2I minus 3I. We have j minus 6j. And we have 18k minus 2k. There's our cross product. It's not too strange. Okay? Because we've known how to take a 3x3 determinant. I realize it's been probably 6 months since we've done it. It is a long time. Well, unless it was on your final, then it would have only been, 4 months ago. But still. Okay, your job now is for you to calculate V cross U. Without me, I would like you to calculate V cross U. Dallas, what'd you get for your cross product?
I got I plus 5K minus 16K.
Any questions for Dallas as to how he got those three numbers? Observations. Ah, notice how V cross U is the exact opposite of up here. That is not a coincidence. U cross V will always be the opposite of V cross U. U cross V will always be the opposite of V cross U. Always. Okay, I'm going to go through some properties. You don't need to write these down. You wrote down this one, which is the most important. Okay, I'm going to go through some of the other ones, but they're in your book. You're not going to need them. I just want to kind of talk through some of them. Okay, so we talked about how U cross V and V cross U are always going to be opposites. Since we are talking about multiplication, is we can use the distributive property. So if we have U crossed with a sum here, we could distribute the multiplication U cross V plus U cross W. Okay. Here with multiplication, we don't distribute multiplication to multiplication, okay? We take one product and then another. So you can either take the cross product and then multiply it to the constant. You can take the constant times one of the vectors and then do your cross product, but you can only do one multiplication at a time. You can't distribute it to both, okay? If you take the cross product of a vector and the zero vector, you are going to get 0. Kind of sounds like you wouldn't even need to put the numbers in there, right? We could just think about it. Here's an interesting one. If you take U cross U, you're going to get 0. Your numbers are going to cancel out when you do all those calculations, okay? And then the last one, this is kind of cool. It says like an associative property, U dot V cross W is the same as U cross V dot W. So their multiplication, right? The cross product and the dot product are both multiplication. So if both are present in a problem, it doesn't matter in which order we do them. Okay, it's kind of cool. Okay. All right, so we are going to make a little discovery here. So we're going to go back to, well, I guess we're not going to discover it. I'm just kind of going to tell you. But we're going to prove it. All right. And I don't remember, and you're going to have to remind me, those of you who took physics this year, did you talk about the right-hand rule?
We didn't. Sounds highly unfair.
Okay.
Electricity, the flow of electricity.
And what's the right-hand rule?
Here you go, Emma.
It goes in through your thumb, like that's the direction of electricity. If you curl your fingers over, that's like the magnetic field direction.
And is there something about like your thumb being like perpendicular?
It's like
I don't know.
We only talked about that once. So.
You only talked about electricity? The electricity is not the right-hand rule that I'm talking about. Okay, so in Physics 2, those of you who take Physics 2 next year, you'll learn about the right-hand rule. Okay, what happens when you take the cross product of two vectors? Your outcome is actually a vector that is perpendicular aka orthogonal to both. So this picture here, here's A, here's B, U and V, whatever you want it to be. We have two vectors, and we take their cross product. The cross product vector is perpendicular to both. Probably should write that down. Yep. U cross V is orthogonal to both U and V. So this comes in really handy. In calculus this year, we wrote the equations of planes. We wrote the equations of lines. And it was helpful to be able to find that perpendicular vector in order to write the equation of a plane. What did we talk about yesterday? Orthogonal vectors. What was special about orthogonal vectors besides the little 90-degree thing? Their dot product is 0. So let's go back to our previous example. We have these two, right? Okay. Riley S., what was our cross product, U cross V?
Negative I, negative 5j plus 16.
Okay. So let's find the dot product. Let's find the dot product of U and U cross V. So basically, I want to take this and find their dot product. So we take 6 times negative 1 and 2 times negative 5 and 1 times 16. So we have negative 6 plus negative 10 plus 16. Okay, just to be sure, I want you at your table to find the dot product of V and U cross V. So these two right here, U cross V and V, find their dot product for me. Are you getting 0?
Yep.
1 times negative 1, 3 times negative 5, and 1 times 16. You should be getting 0. Yay!
Whoa.
Legends. Yes, legends.
Yes.
Wizards.
Nice.
Okay, I think we have
No.
2 more topics. Sorry. Okay.
Fun with geometry.
Yeah. If we have 2 vectors that are both in standard position and they're creating adjacent sides of a parallelogram, then we can find the area of the parallelogram by finding the magnitude of the cross product. Well, you can write, I have them written out for you right here. Just write them down. So the magnitude of the cross product will give us the area of the parallelogram. And you know what? I really could go through the math as to why this works out, but I think we're to the point where you don't really care.
I'm not interested.
want to. If you know what a parallelogram looks like, then maybe you'll be okay without it.
Literally.
All right, so I have an example for us on the next slide. We are going to find the area of a parallelogram whose adjacent sides are I plus 2j plus 2k and I plus k. Okay, so in order to find the area, we are going to need to calculate the cross product. So U cross V, we're going to set up as I, J, K. Vector U would be 1, 2, 2. And vector V would be 1, 0, 1, because there's no J, so we're going to put a 0 there. We'll copy paste. So our down diagonals give us 2I plus 2J. Don't forget anything times 0 is 0. Minus 2K plus 0 plus J. So our cross product ends up being 2I minus 0, 2J minus J, so that would be just plus J, and then 0 minus 2K. Okay. All right, we found the cross product. What do we do with our cross product? Okay, if we want the area of our parallelogram, we need to take the magnitude of this cross product. So we're going to take the square root of component squared plus component squared plus component squared. Oh, what's our magnitude? And we are talking about area, so we are talking about square units, whatever those units may be. One more slide, guys. One more slide. Are you ready?
Yeah.
Let's finish it out. Finish strong. Finish strong.
Let's do it.
Oh.
You have to do us like that.
Okay, we have something called a triple scalar product. And you know what? This is all I would write down right here.
Oh, I thought you were supposed to say the topic.
So write down that it's a triple scalar product. But take a time out from writing real quick and look at me. Do you see how this is U dot V cross W? So instead of finding the cross product and then doing another step of the dot product, what we can do is we can put U, V, W, all three into the determinant and only have to do one calculation. Write it down. Since we have a dot product of two vectors, our answer will be a scalar, which you can see, you're going to just put a bunch of numbers in that determinant. So your answer is going to be a scalar. So the triple scalar product, just in order, make each of your rows the different components of vector U, V, and W. Write down these 3 vectors, and this is going to do it for us. It's our last example. So our triple scalar product. We're going to put 2, 0, 1 in the first row, 3, negative 1, 2 in the second row, and negative 1, 5, 2 in the third row.
The last two is negative.
Oh, yes, thank you. Thank you, thank you. Did I get all the rest? Okay. So, copy paste. What's nice about the triple scalar product is we don't have to keep track of those i's, j's, and k's. We just have numbers. So we have, give it to me, plus 0 plus 15 minus the sum of 1 plus, what did I hear?
20.
Okay, I thought I heard 40. Plus 0. So we have 19 minus 21. Our triple scalar product is negative 2.
That was it.
We did it! Give yourselves a pat on the back. And you have 9 minutes to start this homework assignment. The more you can get done, the better. Yes. Addie, will this make more sense now?
Yeah.